Hello, and we're now going to look at dividing indices. So just recapping, because it's good to just link maths together, we're going to look at multiplying. Now, the key thing with all of these rules, with multiplying indices, when we're dividing, our base needs to be the same. So you can see here, I've got a base of 4 and I've got a base of 4. And I'm hoping you can remember that that is 4 to the power of 7. Why is it 7? Because there's a 5 and a 2 and we add. So when our base is the same and we're multiplying, we add the indices to get that new power, and it's the shortcut, because if you look at the video I've done on multiplying indices, I explain why that works, because what 4 to the power 5 is, what 4 to the squared is, and that actually that's the same as 4 to the 7. So we're now going to look at dividing. Is there a quick rule here? Is there a rule like multiplying? So let's think about this. Maybe you could even come up with an idea of what it might be. So here we have two values written in indices form, and their bases are the same. So both of the bases are the same. We've got 5 and 2, we add them together and we get 7. What do you think we're going to do when they're dividing? Well, the answer can't be the same when you divide, can it? It's got to be a different answer, because when we multiply two numbers, most often we get a different answer than we divide. Can you think of the example that's not right there? 1 and 1 is 1. 1 times 1 is 1. 1 divided by 1 is 1. So there's one that breaks the rule. But what I want you to think of is I'm expecting a different answer here. So I don't think I could be adding these. So what do you think I could do when I divide? Bases are the same. What could I do? Well, let's see. Let's work it out. So 4 to the power of 5 means 4 multiplied by 4, multiplied by 4, multiplied by 4, multiplied by 4. That's what 4 to the power of 5 means. And it says divided by 4 squared. So divided by, that's that line all the way across the bottom, 4 squared, which is 4 multiplied by 4. That's what that calculation means. It means 4 to the power of 5 divided by 4 squared. Well, if we do some dividing now, and remember equivalent fractions, and this is where all our knowledge in maths links together. So equivalent fractions is where we can divide the numerator and the denominator by the same value, and it's still worth the same amount. So I could divide the top and the bottom by 4. And I'm going to do that by crossing one out. Because if I divide the top by 4, I'd be left with 4 multiplied by 4, multiplied by 4, multiplied by 4. And if I divide the bottom by 4, I'd just be left with 4. Well, I can divide the top and bottom by 4 again, and I'm going to do that by just crossing them out. And I'm just left with 4 multiplied by 4 multiplied by 4 on the top. So I'm just left with that on the top. And what's that the same as? 4 to the power of 3. Oh, let's look at these numbers. That's 4 to the power of 3, and that's a 5 and a 2. What's the link between 5, 2 and 3? I'm hoping you're seeing its subtraction. So what we can say from this is, when you have two numbers here, or two indices, where we have the same base, so we have the same bases here, we can subtract the indices to get a simplified answer, but only when the bases are the same. So when we're multiplying, we add the indices. When we're dividing, we subtract those indices. So multiplying, we add. Dividing, we subtract. only works when the bases are the same. So this one here, we're dividing here. So let's do it the long way just to check. So 5 multiplied by 5, 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 divided by 5, multiplied by 5, multiplied by 5. Now, let's see. 5, 5, 5, 5, 5, 5. So I'm left with this, which is 5 to the 4. Does my subtraction rule work? Let me check. Yes, it does, because 7 subtract 3 is 4. So this is a new shortcut rule. But you must understand where it comes from, because when you forget, we all forget things, what you need to do is be able to go back and just remind yourself. So here, bases must be the same. And remember, then here we subtract to get that 4. Right, so what's the answer to these two? Right, have a go at the first one. Can you do it? So I'm hoping you've had a go. 3, and what am I going to write? Well, it's 4. And because I'm dividing, I've got to take away 7. Oh, I'm going to get a negative number. 4 take away 7 is negative 3. There's my answer. 3 to the negative 3. What does a negative indice mean? Ah, yes, that means that it's 3 cubed, but I'm going to write 1 over 3 cubed. Do you remember? Just a bit of a reminder, that's what that means. That negative means that you're dividing 1 by 3 to the power 3. It's the reciprocal. So, what about this one? Now, be careful. There's a bit of a nasty bit going on here that I've slipped in. What do you think the answer to this is? The bases are the same, so I know that's going to be 3. What do you think the power's going to be? What's that indice? Now, I'm hoping we've got the right answer, but just be careful, because this is 5 subtract negative 2. I'm subtracting a negative number. Oh, 5 subtract a negative number. I go up the number line. This is where our negative numbers are really important, because I'm subtracting here. So it is 5 subtract negative 2. So that's the same as 5, and I'm going to go up the number line too. So my answer is 7. Did some of you perhaps write 3? Don't get caught out. Now, this is why this is up there in those grades that allow us to get that grade 4, that grade 5. That's why this is there, because it's that extra bit of thinking. You've got to get your negative numbers right. You've got to remember the indice. Well, you've got to put it all together to get to that next level. So if that's confused you, you need to go and look at your negative numbers. Negative numbers are so important. So 5 subtract negative 2. We're going up the number line, so we're at 5 and we're going to go up 2, because we'd usually go down 2 when we take away, but as we're taking away a negative number, we go up 2. Right, let's have a go at another one. Ooh, so now we've got lots of things going on here. We've got some multiplying, and then this here on the bottom is dividing. So first of all, I'm going to do this bit on the top, because I like multiplying. I'm good at that. So that's going to be, I've got both bases are the same. They're both 6. I've got a 2 and a 4, and they're multiplying. So what's the rule for multiplying? I add, and then I'm going to just leave the denominator the same at the moment. Now, this here means that I've got this divided by this. So my 6 to the power 6 divided by 6 to the negative 3. Now they're dividing. So what do I do with my powers? I subtract. So I'm going to subtract. So I'm going to go 6 subtract negative 3. Now if I'm subtracting negative 3, I'm subtracting a negative number. And when I subtract a negative number, I go up the number line, because the way to think of negative numbers is 6. If I was just doing 6 take 3, 6, and when I take away 3, I go down the number line. But when I do 6 subtract negative 3, I go up the number line. So I'm at 6, I go up the number line 3, so it's 6 to the power of 9. Now, if you're getting stuck, and I'm going to say this again on why this is 9, it's to do with negative numbers. And negative numbers just keep coming up in maths. They're actually a skill you learn in years 7 and 8. And when you learn them, it's all great. But, you know, as maths develops, they become quite tricky. And this is where I think they are tricky. So going back on that again, 6, because we're subtracting negative 3, we're subtracting negative 3. Rather than going down the number line 3, we go do the opposite and we go up the number line 3. So let's do one last example. So here we're going to do again, it's best to do this top part first, and as they're multiplying. So we've got the same bases and they're multiplying, so we add the indices. So here's my indices and I'm adding them. Now here it's 8 add negative 2. Now when you add a number, you usually go up the number line. You go get bigger when you add, but when you add a negative number, you go down. So, and it's really understanding, if you add a negative number, rather than going up the number line, you go down. If you subtract a negative number, rather than going down the down the number line, you go up. You always do the opposite if you think about it. So here I've got to do 8 add negative 2, and as I'm adding a negative number, I'm going down the number line. So that would be 4 to the power 6, and that would be over 4 to the negative 3. Now these here is 4 to the power 6 divided by 4 to the negative 3. As we are dividing, that means we are going to subtract our indices. So it is 6 subtract negative 3. I'm subtracting a negative number. So I don't go down my number line, I go up my number line, and I'm going to go up 3, and so my answer is 4 to the 9. Okay, might need to rewatch that, might need to choose to recap your negative numbers, because that's what can cause the problems.